Ya, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh dan selamat petang Jadi, kita tengok we are looking into chapter 2 programming paradigm. Generation of programming language. One is just an overview of programming language lah. Okay, first generation we 1GL is for first generation Then we got second generation, third generation, fourth generation, and fifth generation. The first generation basically for machine language, direct binary code, 0 and 1, and extremely low level and hardware specific for the first generation. The second generation basically for the assembly language. Uses mnemonics to represent machine instruction and still low level but more readable uh, rather than first language, first generation. And then we have a third generation, high level languages. For example, we have C, C++, Java, Python. This one for the third generation. More abstract, closer to human language. Meaning to say that it is very understandable compared to second and first generation language platform. And for the platform itself, it is independent to varying degree. It is platform independent. And then we have fourth generation language, very high languages, domain specific language. Especially we have SQL, R, MATLAB. This one is very high language, focus on specific problem, domain or type of applications. And then we have a fifth generation constraint based and logic programming languages. Example, we have Prolog, Mercury. The main objective is to solve problem by stating constraint rather than specifying step. This one more on the last week. We have more on the programming paradigm. Okay, this one is first generation language. Okay, first generation language was still is machine language. Binary format consists of entirely binary 0 and 1. Each instruction is a sequence of binary language. And then for the hardware specification, unique to particular computer architecture, which means it's not portable between different type of processor. And then for the direct execution, no translation needed. CPU execute instruction directly, which means that faster execution among all programming languages versions. This one we call it as also as a native machine code. For the difficulty, extremely difficult to human to read, because it is based on starting of 0 and 1. And then for the memory addressing, we can show that uses direct memory addresses for data and instruction manipulation. This one is no abstraction, which means that like high level construct like variable, function, and control structure. There is no control structure, no variables, and no functions. And then for example, we can see your right hand side is whereby 10 or 11 0 0 0, which mean that opcode for move, and 0110 001, the opcode, the code might be memory address or data value. The usage for the early computers, primary method of programming in early methods in 1940s until 1950s. is for the modern application, we have embedded system programming, writing device driver, and performance critical section for operating system. This one is for the first generation language. Okay, and then we have second generation language. Okay, this one is we call it as assembly. Assembly assembly languages. It's a low-level programming language that uses mnemonics to represent the machine code instruction. Characteristic is very symbolic representation. It uses the human readable mnemonic and symbols instead of binary code. It represent differently from first first generation language. And then architecture specific tied to a particular computer architecture or processor family lah. Different assembly language exist for different processor architecture. Okay, and then the program written in assembly language need required to be converted to machine code by assembler. Okay, normally we commonly known as GAS or AS. For example, we have move AX to 5. One is move the value 5 into AX register. Okay, the usage is widely used in early computing, 1950 until 1970s. For the modern application, writing device drivers, developing operating system kernels, okay, the core of the operating system, we name it as a kernel. For the educational objective is to understand computer architecture, learning low-level programming concept. For the advantage, differently from the first generation language, this one is to allow for high optimized code when written by a highly skilled programmers and provide precise control over hardware and also the resources. The advantage also is more readable than machine code. Okay, is it okay right now? Boleh ke? Fiona? You okay?
Okay, Doctor.
Okay, we go by the third language. If you have any question, you can ask lah. Okay, third generation language are high level programming language that more abstract than user friendly compared to their predecessor. Compared to first generation and second generation language. They are use English-like commands and are designed to be easier for human to read and to write and also to understand. The key characteristic for third generation language is more on machine independent, use of mnemonic and symbols also, closer to natural language processing (NLP), and compiled or interpreted. Very common example include we have C, C++, Java, Basic, COBOL, and Fortran. Okay, and then third generation language mark a significant advancement in programming, making a software development more accessible and efficient. And then we have fourth generation language. Okay, fourth generation language is designed to be closer natural language rather than third generation language. Fourth generation language highly high level language that are closer to human language and further from machine code. They are designed to reduce the time and also effort and specialized skill required to develop the software. As you can see here, we have machine here. Then we have human, human more to natural language. Okay, and then we have first, second, third, and fourth, and also the fifth generation. We have natural language processing. Okay, and then key characteristic, declarative nature. User often specify what they want to achieve rather than how to do it. And then for the domain specific, we have 4GL, 4GL for fourth generation, tailored for specific application area. Type of fourth generation language is we have SQL. We have report generator, example Crystal report. Data manipulation languages such as SAS, SPSS. One is fourth generation. And application generators such as Oracle, Apex. Some are very high general purpose languages such as Python. The advantage to increase the productivity, easier maintenance, improve code quality, accessibility to non-programmers or domain expert lah. And then the last one will be rapid prototyping and development. They also have some disadvantages. For example, potentially lower performance compared to third generation language because it is more on the application. Less flexibility for complex low-level operation and maybe overkill for a simple task. And often proprietary and platform specific. It is more expensive. Okay, and then fourth generation language was emerged in 1970s until 1980s and also 1990s. We have first one is machine code. Second generation language is more an assembly language. Third generation language is high level languages like C and Java. Fourth generation language very high level, often domain specific language. And then we have fifth generation language, constraint based and logic programming languages. Okay, this one is fifth generation language. Okay, for the fifth generation language, okay, we have programming that uses more visual, designed to make a computer solve a given problem without the programmer needing to specify the algorithm used in the solution. The main objective is to be closer to natural language and further from machine code that have explained in a previous generation language. And then for the key characteristic, we can see for the third and fourth generation language. For the fifth is constraint-based programming. Problem are stated in terms of constraint and goals, more on the abstraction. And then extremely high level of abstraction, focus on solving problem using constraint rather than algorithm. The core concept is declarative programming. As we can see last week, I've explained to you declarative programming. More to specify what need to be done, not how to do it. The constraint satisfaction define problem as a set of constraints to be met. And then we have logic programming based on a formal logic. Example of implementation, we have Prolog, we have Mercury, we have OP S5 and ICAD. 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 ICAD is a fifth generation language. And then application area for this time is more on artificial intelligence research, expert system, natural language processing, automated theorem proving. And then we have language abstraction. Okay. Okay, for comparison with the earlier generation, first generation language is machine code. Second generation language is assembly language. A third generation language is high level procedural language. Example C and Java. Fourth generation language is very high level, often domain specific language, example SQL. And then fifth generation language is constraint based and logic programming languages. Okay, we go on the language abstraction. Okay, language abstraction is amount of complexity which system is used or programmed. Okay, basically, language abstraction is degree which programming language shield from the programmer from the underlying hardware detail and low level operations. Okay, level of abstraction from lowest to highest. First one we have in code, first generation, then second generation, third generation, fourth generation, and fifth generation. Key concept is abstraction increases, syntax become more English-like. This one, the higher level, the less detail. For the semantic, we have higher abstraction language, have more complex built-in operations. The higher level abstraction is the entire system lah. And then for the portability, higher abstraction often lead to greater platform independence lah. Benefit for higher abstraction, increased productivity, easier to learn and use. Then often lead to fewer errors. And then abstraction mechanism. We have a virtual machine. For example, for Java, you need to install the Java virtual machine, Java VM. And then for the domain specific abstraction, we have database queries in SQL. Impact on software development process, enable division of labor. Example, we have system programmer versus application developers. Is two different division, and it also allows for specific specialization in particular domain. The trend nowadays, we can see that general trend towards higher abstraction over time lah. It for the domain specific language for specialized tasks. And then now we have a visual programming environment. Okay, and then as a conclusion, we can say that language abstraction is a very fundamental concept in programming language language design, influencing how we can approach the software development and interact with computing system. Okay, so far, do you have any question?
Okay, Doctor.
Yang baru masuk. Pak ini Sofia ni internet tak stabil ke?
Ya, doktor.
Okay, and then we have mission code. For the code, mission code and mission language are directly executable by computer CPUs. Okay, mission code is a set of binary instruction that can be directly executed by computer CPU. It is often called first generation language. Okay, and then the key characteristic for machine code is a binary representation, processor specific. Each type of CPU has its own machine code instruction set, represented by octal or hexadecimal, and then directly executable. No translation needed before execution. And then for the structure, we have operation code, or opcode, and then we have operand. Yeah, and then for instruction type, we have data movement. For example, we have load, store, it's very direct input. And then we have arithmetic and logic operations. And then we have control flow. For example, we have jump and branch. This one more on input-output operations. For the advantages, for the execution speed directly interpreted by CPU is very fast. For memory efficiencies, compact representation, and then full hardware control. For the disadvantages, we extremely difficult to human to read or write because it is more on the octal or the hexadecimal. Not portable between different CPU architecture and time consuming. For the modern usage, while rarely written directly, machine code is generated by compiler and assemblers. They are used in embedded system and device drivers, studied in computer architecture and low-level programming courses. For example, here we have ARMS x86 and MIPS. This one is for the early machine code. The next, we have assembly language. Okay, for assembly language, is directly correspond to a machine language. It's a low-level language that provides symbolic representation or machine code instruction. It's often referred to second generation or key characteristic is symbolic representation uses mnemonic. This one is just a broad explanation from the second generation language. Architecture specific, different for each CPU architecture. They have their own architecture, and then they require assembly that let programmer use the symbolic address. For the structure, we have mnemonics, abbreviated words represent operations. For example, we have move, add, add for add, and then JMP for jump. Labels, symbolic name for memory addresses. Okay, command for human readers, ignored by the assemblers. For the command, it also have some comments. Okay, for example, we have move AL. Okay, we have a data movement, move. We have arithmetic, addition, add, ADD, SUB for subtraction, and then we have logical operations. We have control flow, and then we have comparison, CMP, compare and test. Okay, this one is more on the assembly language. For advantage, direct hardware control for the efficiencies can be optimized for specific hardware. Useful for specific tasks. For example, we have device driver, bootloaders, embedded system, and so on. For the disadvantages, difficult to learn because it uses high-level languages, and then time consuming to write complex program. Very high, very time consuming. And then the next disadvantages is not portable between different CPUs architecture and prone to error due to its low level nature. For example, we have relationship to other languages, lower level, then we compare to high level. For example, we have C and Java. High level, then machine code often used as intermediate representation in compilers. Okay, and then we have middle level language. Okay, middle level language, or we can call it as MLL. Programming language that combine features of both low level and high level language. They offer balance between machine oriented and problem oriented programming. Combine both. The main characteristic for MLL is abstraction level, higher than assembly but lower than purely high level languages in between. In between high level and low level languages. For the hardware access, provide some degree of direct hardware control. The primary example, we have C, often considered the quintessential middle level language. And then we have C++, extend C with object-oriented features. Okay, and then we have Java bytecode, JBC. This one, the features with direct manipulation, bit level operation, access to system cell, and so on. For the advantage, we can see that middle level language can balance the control and also abstraction because it's combination of high level and lower level. And then it also require more attention to detail like memory management lah. And then can be prone to error like buffer overflows. And then the last one is less abstract than higher level language for complex applications. And then for the last one, we have high level language. Okay, high level language. Okay, for this one, high level language are designed to be more abstract. More abstract, which means that it is more understandable, user friendly, and closer to human language compared to low level or middle level language. It is more understandable. They also allow the programmers to write the code that is independent of a particular type of computer. For the key characteristic for abstraction, hide complex implementation details. And for the readability, easier for human to read and write, because we have C++, C Sharp, Algol, Pascal, Java, VB, VBScript, Visual Basic. Portability can run on different hardware or minimal or no changes. It can run different platform. And then productivity enable faster development of complex applications, and memory management often handle memory allocation automatically. We have high level languages include Python, Java, JavaScript, C Sharp, Ruby, Swift, Go, and Kotlin. Kotlin. Can search for Kotlin. Uh, okay, this one is Kotlin programming language. Test the Kotlin programming language. Okay, set off. The program Kotlin programming language is a modern open source statistically typed programming language that run on the Java Virtual Machine JVM. It is fully interoperable with Java and provide additional features to enhance productivity code. Developed by JetBrains in 2011. Version 1.0 released in 2016. You can have here. And then click on get started. JetBrains. Then you can explore later. Yang ni pernah dengar tak Kotlin ni? Kan pernah cuba Kotlin ni?
Tak benar Doktor.
Okay, try lah. Dia based on Java. It have platform Android. We have web development, can compile to JavaScript. Native can compile native code for iOS and also for desktop. This one is for the Android development. Can explore later. Kotlin. Okay, and then okay, and then we have very high level programming language. Okay, very high level programming language VHLL is programming language with very high level of abstraction. Uh, they are designed to be closer to human thinking and also for the natural language. High level thinking, which means that you can have abstractions. Focusing on problem domain rather than implementation detail. It is more on the programming side, abstraction side. The key characteristic is high abstraction, problem oriented, concise, domain specific, and productivity focused. Okay, we have example SQL, R for the statistical computing. We have MATLAB, we have Python. Also, we have Prolog, R language. Search in R language basically for computing statistical. You can download this one. R project for statistical computing. One for the statistic equations. Yeah, for the advantage, we can see that it is rapid development, faster to write and faster to develop a prototype. And reduce cognitive load. Developer can focus more on the problem solving because it uses domain specific language. For the accessibility, easier for domain expert who are not professional programmers. And for the maintainability, often easier to read and to understand because it is more to natural languages processing. And portability, usually more platform independent. Disadvantage, performance overhead, generally slower than lower level language. Limited control, less fine-grained control over system resources. And then for the learning curve, can be steep for those who are using procedural thinking. Okay, we have artificial intelligence for expert system. We using Prolog and Libs. Rapid prototyping and scripting, we have Python and Ruby. Ruby, Aisyah Farhana pernah guna Ruby ke? Ruby programming language boleh check nantilah. You can download Ruby nanti kita akan explore Ruby Ruby, Libs, programming and so on lah. One is more on the very high level language okay. Tati pernah cuba ke? Balkis pernah cuba Ruby ke? Soal ni ada ke tak ada? Ke saya tak dengar?
Oh, ada Doktor.
Kamu tidur ke? Baik,
Tak pun.
Ruby nanti kita akan tengok Ruby, kita akan download Ruby dan tengok macam mana. Okay, and then we have a visual modeling language. Okay, visual modeling language is graphical representation. More on the graphical representation for object and also system. Yeah, using graphical languages. They also provide a standardized way to visualize, specify, construct, and also document the artifacts of software system and other system. The main characteristic This graphical representation use symbol, shape, and connector to represent concept. For the standardization, we provide common vocabulary for the system design. For the abstraction, allow complex system to be represented at various level of details. And then for the communication, facilitate understanding between stakeholder. For example, we have UML, Unified Model and Language. We have Business Process Model and Notation, BPMN. And then we can also have Entity Relationship Diagram, ERD, Flowchart, State Machine Diagram, and Data Flow Diagram, DFD. Okay, for the component, normally when you want to represent VML, is using entities, action, and also states. And then type of diagram, we have structural diagram. For example, represent static aspect of the system. You can use UML class diagram. And then for the behavioral diagram, so show dynamic aspect and interaction. For example, we have UML sequence diagram. Sequence, which means that you can have behavioral diagram. And architectural diagram depict the high level system structure. And then for process flow diagram, illustrate workflow or algorithms. Okay, the challenges is learning curve, require time to learn and master lah. For the over complication, you can see can become too complex, if not managed well. It is often required specialized software for creation and editing. Then popular tools, we have Enterprise Architect, Visual Paradigm, Lucidchart, Microsoft Visual Draw.io. One you can test. This one is we call it a visual modeling language. Lucid. This one is more on the representation. Can sign up free. This one by apa yang buat ni? I think by Microsoft. One we can have the file, can generate the flow. Okay, Lucidchart. Lucidchart is based web-based programming and visualization application that allow user to collaborate on drawings. Key features, it have a cloud-based, collaborative, versatile, and user-friendly. And for the type of diagram, we have flowchart, organization chart, UML diagram. Okay. Limitation, internet dependency, requires internet connection for full functionalities. Okay, and the learning curve, advanced feature may take time to master. And then the cost-free version has limitation. Full feature require some subscription for pricing. Pricing, I think it quite $10 per user. And then for the enterprise, you can contact the sales. $10 is around 43 ringgit. 43 ringgit monthly lah. Okay, so far do you have any question? Boleh ke? Ada berapa slide lagi ni? Oh, ada 26 slide. Kita dah slide yang keberapa ni? 14. Any question? Ada soalan ke?
So far tak ada.
Tadi ada.
Okay, this one we have discussed a little bit last week. Programming paradigm refers to basically the style. How you want to build the structure and also the element. There are several features to determine the programming paradigm such as modularity, interruption or event or control flow. The programming paradigm have two main structure, imperative and declarative lah. For imperative, that more on the object itself, we have procedural and object oriented lah. For declarative, we want to go step by step. We have functional, we have logical and mathematical. Okay, we go by one. Okay, imperative programming. Okay, for the imperative programming is a programming paradigm that use statement to change program state. Focusing on describe how the program operate step by step. User sequences use the step by step 1, 2, 3, 4, and then relies heavily on the variable and also assignment. And then control flow is managed through loops and conditionals. Common languages like C, Python, and Java. We also have COBOL, Algol, Basic, Fortran, and Ada. This one is imperative programming. For the key characteristic, it is explicit instruction, mutable state, and sequential executions. The program is sequenced to order and unconditional jumps between them. Okay, we have imperative programming. User statement that change program state. Okay, for the example, for imperative programming, okay, we can have some programming in Python. Python, we can calculate sum. This one is more on a step by step. We total up the sum and then we go by the loops and so on. This one is in Python. We have also in several languages. C, Python, and Java. Okay, and then we have declarative programming. For the declarative programming, is programming style. Programming style of building a structure and element of computer program. That focusing what the program should accomplish, and not how to accomplish it. Okay, describe the desired result rather than step-by-step procedure. One I explained last week. Often uses expression instead of statement. Minimizes or eliminate side effect or state changes, common in functional programming language and also in SQL. For the key characteristic, emphasis on expression over statement, immutability when possible, higher order function, and abstraction of control flow. Describing without describing it control flow. Okay, note that many programming language cannot be strictly classified into one paradigm. It rather include in several paradigm because of what? Because of the high order functions. Okay, this one is declarative programming. We have logic and functional. Okay, this one is imperative. Imperative more on the structured, procedural, and modular programming. We have pros, advantages, and disadvantages. For the imperative programming, implementation of all idea and requirement, more on qualitative project realization, unique opportunities. For the contrast, highly qualified resources. It's more expensive. For declarative, less qualified specialists, okay, it can be implemented for the unexperienced programmer, short development terms or durations. Okay, the uh, disadvantages is simplifications. Refusal form part of functionalities and loss of project unique qualities. It is not uh, focusing on the quality. Okay, we have procedural programming languages. Okay, this one is step by step. Okay, procedural programming is program paradigm that derive from imperative programming. Based on the concept of procedural call. Basically, for the procedural programming is programming that closely related to imperative programming. It based on the concept of procedural call, where the program is structured as a sequence of procedure, as known as routine, subroutine. We have some terms or functions to be executed. The core concept for procedural programming organize code into procedure rather than perform specific tasks. The key characteristic. Okay. First one, you can see it is a modularity. The code is divided into smaller, manageable and manageable unit like procedure. We have procedure. This one modularity. Second one, we have top-down approach. Problem are broken into smaller sub-problems. Each sub-problem is solved with a specific procedure. And then we have a sequential execution. One control flow is managed through procedural call, loops, and conditional. And then use some variable. Emphasis on algorithm. Okay, we have procedures. We have predefined function, local variable, global variable, modularity, and parameter passing. Advantage: simplify complex problem by breaking down them into a smaller part or smaller sub module. Promote code reuse through procedures, efficient for solving linear problems. Disadvantages is can lead to spaghetti code. Okay, spaghetti code is problems. Spaghetti code problem significantly hinders collaboration among developers. It can lack communication between developers because of the spaghetti code. Its complex and unstructured nature make it difficult to read, make difficult to understand, and modify, leading to increased debugging time and decreased productivity, which means that it called as spaghetti code. Bukan spaghetti yang makan tu spaghetti code yang apa dinamakan terms dia spaghetti code. Okay. We have and also may not be suitable for modeling real world object as object oriented programming. Dia tak sesuai untuk object oriented programming. Can be less flexible than other some paradigm for large complex system. For example, we have a common procedural. We have C. We have COBOL, Fortran, Basic, Pascal. And then many scripting language such as Lua and Bash. Pernah dengar tak Lua and Bash? Lua and one is more on scripting language. Basically Lua and Bash, when you learn Linux, you can use Lua as a Bash alternative lah. Okay. Sikit lagi nak habis. Okay, and then we have object-oriented. It's very similar to you guys because it is more on the object that can contain data and code over the form of field that can acknowledge as a attribute or property or characteristic. A feature of object is known as motion of itself. For example, we have instantiation. We have classes, and then we have instances of the class, which determine their own type. For example, we have Java, we have C++, we have C#. This one is object-oriented language. Then we have functional programming language. Okay. For functional programming language, a program that treats computational as the evaluation of mathematical function and avoid changing state and mutable data. Okay. The core concept of functional programming based of lambda calculus, a formal system in mathematical logic, lambda calculus. Emphasis on the application function to input to procedure output. The key characteristic of pure function, and then we have immutability. Data cannot be changed after it has been created. And then first class and higher order function. Function can be assigned to variable. Function can be passed as argument, same as object oriented. Function can return from other functions. Okay, common features we have algebraic data type, we have pattern matching and so on. Okay, for common functional programming language, we can have Haskell, Lisp, okay, Erlang, Elixir, F#, okay, Scala, F# programming, F#, like this programming. F# is JavaScript. JavaScript is a very fundamental Java, and F# is open source. Is JavaScript and .NET language for web, cloud, data science apps and more lah. Dah dengar ke F# ni?
Tak ada.
Boleh cuba nanti boleh try and error F# ni. Sikit je lagi, lepas tu kita habis. Nanti saya akan bagi rakaman dalam YouTube YouTube saya nanti kalau nak subscribe boleh subscribe Boleh tengok lah untuk you all punya exam nanti.
Okay.
Okay, and then we have logic programming language memang boring sikit lah. Sebab yang ni kita belajar fundamental of programming flow Nanti next week kita akan tengok daripada segi principle design. Kita akan tengok data type lah macam mana. Question, so on. Okay, logic programming is programming a paradigm based on a formal logic. It is fundamentally different from imperative, functional and object-oriented. Dia berlainan sikit lah. It's very different. The core concept is computation is treated as automated reasoning over body of knowledge. Program are expressed as logical statement based on the facts and rules. And then execution is query that system try to prove based on the given fact and rules. This one based on the reasoning. Key characteristic is declarative nature. Okay, focus on defining what the problem is rather than how to solve it. Okay, this is more on the problem. The programmer specify the logic and system determine how to use it. Okay, for the knowledge base, the program consists of a set of facts and rules. And then for common features, it is more on the pattern matching. Backtracking, built-in search capability and support for symbolic computational. For computer program, we call it as predicates. Predicates are used to build atomic formula. This one more on the last time I have teach formal method. This one more on the formal method in computer science. For predicates and so on. This one more on the discrete mathematics. I think you have took discrete mathematics before. Dah ambil belum discrete mathematics? Dah kan? Belum lagi? Islam dah ambil dah?
Discrete.
Ha.
Dah rasanya.
Dah. And then common logic programming language is we name it as Mercury, Prolog, Datalog, answer set programming ASP. This one is very common application. We have artificial intelligence and expert system, automated theorem proving, database query languages and constraint logic programming. Okay, and then mathematical programming language. This one or more on the calculation. Okay, mathematical programming language are specified language designed to express and to solve mathematics. Mathematical problem, particularly in field like optimization, statistics, and numerical analysis. Okay, the key characteristic is syntax close to mathematical notations, built-in support for complex mathematical operations. The common features is metric and vector operations. We have support for symbolic mathematics. Type of mathematical programming language, we have MATLAB, we have mathematics, we have Maple, we have SageMath. This one is general purpose. SageMath. Spelling like this. SAGEMAT. This one is open source mathematical software system. This one is more on NumPy, SciPy, Matplotlib, Flink, R, and more. One is more on open source. Then we have statistical programming language. Such as R and SAS. SAS. Programming language. It is more on the data science, machine learning, and artificial intelligence. But if you want to know, you can learn SAS programming. More on the statistical. And then optimization focus language, we have AMPL, a mathematical programming language, and GAMS, general algebraic modeling system. And then for the numerical computing language, we have Julia, we have Octave. Octave is alternative source rather than MATLAB. Octave, OCAVE. octave. You can draw the scientific computing like this. One is very fast. The computational. Can download this one octave. This powerful mathematical oriented with built-in 2D or 3D plotting and visualization tools can run on many platforms like Windows, Mac OS, Open BSD, Linux. Compatible also with MATLAB script extensions. Can be run also in UI mode like this. Can test okay, if you interested in mathematical plotting. Okay, you can test octave. Octave. So far, any question? Is it okay? Okay, and then we have runtime characteristic. Okay, another trick slide. Runtime characteristic is common language runtime based on class library support. This one is more on the characteristic that define the data, and every programming language has a system that checking the common values for runtime and type checking. For example, here we have thread support, we have COM, we have type checker, security engine, and also class loader. Then dynamically typed language, we have implementation that runtime type information. For example, we have Python, JavaScript, Ruby, PHP, Erlang language, Perl, Lua, Smalltalk, and Lisp. And finally, we have statistically typed language. Statically typed language. Okay, statically typed language is a process of verifying the type of safety program based on analysis of a program text. Basically, the core concept is variable type are known for check before the runtime. Type checking occurs during compilation, and key characteristic explicit data declaration. Number 2 is compile time type checking, type safety, and performance. Okay, there are four types. Then advantage early detection of type related error. Okay. Then can lead to more robust and less error prone code. Okay, for the challenges can be more verbose due to explicit type declaration, less flexible than dynamically typed languages, and may require more initial development time. Common statically typed language, we have C, Java, Rust, Go, Haskell, Kotlin, Swift, Scala, OC, OCaml, Delphi, Reason ML, and so on. Because we have code, we have compile time and runtime. Statically is basically the static type checking, which means that it can be optimized the programming compiler. I think that's all for today. Next week we go for chapter 3. Some exercises.